Today we're going to learn what it is about how neutral atoms form ions. We're going to look at group 1. Everybody in group 1 has a S1 configuration. When group 1 loses their one valence electron, they end up with the noble gas configuration in the row above. Everybody, all of the elements, will either lose or gain electrons in order to get a noble gas configuration, because everything in nature likes to be in the most stable form that it can achieve. And the noble gases have that configuration with a field with an S2 and a P6. So the group 1 metals, they lose their one valence electron, and if you look at lithium, after it loses its one valence electron, it will have the noble gas configuration of helium. Sodium, after it loses its one valence electron, will end up with the neon electron configuration, and so on with potassium. We'll end up with argon, and rubidium will end up with Kr, and so forth. Now then, the reason they do this is to attain these noble gas configurations. If you look at lithium, okay, here's its nucleus, all right, and it has 2 electrons out here and 1 out here for a total of 3 electrons. Okay, lithium has 3 protons at a +1, gives a total charge of 3+. It also has 3 electrons at a -1, gives it a 3- charge, and the sum of the charges on the neutral atom of lithium goes to 0. Now, when lithium loses this electron in the bonding process, okay, now it's gone, leaving it with a 1s2 configuration. Which is helium's configuration. Now then, so when we lose 1 electron, we have lithium now with 3 protons, which equals a 3+, and we have lithium with now only 2 electrons, which equals a 2-. And when you do your math, you come up with an ionic charge of +1. An ionic charge is the charge an atom will have once it has gained or lost electrons to become an ion. So, all elements are neutral. The sum of their charges equals 0. When atoms gain or lose electrons, those atoms are no longer neutral. They have become ions. Now then, everybody in group 2 have 2 valence electrons. So when group 2 loses its 2 valence electrons, it leaves an ion of 2 plus. I need to kind of back up for just a minute. All metals lose their valence electrons, and all nonmetals gain extra electrons. So what does this look like? A nonmetal, let's say fluorine, has 9 protons, which equals a positive 9, and 9 electrons, which equals a negative 9, which adds up to 0. Now then, fluorine lives in group 7 or 17, and has 7 valence electrons. It needs 1 more to have a noble gas configuration. So fluorine, when it gains 1 extra electron, it still has 9 plus 9 protons, and now it has 10 electrons which equals a -10. And when you do the math, you see it comes out that group 7 carries a -1 charge. Okay, so we're going to look at the charges for the groups. Again, all metals lose and your nonmetals gain. So on your periodic table, above group 1, we have their ionic charge in group 1 is +1. Group 2 is +2. Okay, we skip the D because they're not in the main elements and they tend to have multivalence ionic charges. And so in group 3 is +3. Now halfway down we've got +4 and -4 because we've got our nonmetals going here and then metals below. And then we run -3, -2, and -1. And then of course the noble gases are 0 because for our purposes basically only a few of them ever bond and form compounds. So this is how I need you to label your periodic table. Going across like this. And these are your group ionic charges. Now remember, hydrogen is not a metal, but it will lose its 1 valence electron to bond with other things. It can act as a cation. And we will deal with the D block later on when we learn about their naming system. Okay. If you go to your worksheet, we are going to fill in this little table. The group number, where I'm going by the Roman numeral numbers with the A, they're the representative element numbers. So 1A, in group 1, the electron configuration ends as an S1. The number of valence electrons is 1. They lose their valence electron, and they end up with an ionic charge of +1. Group 2A is an S2. They have 2 valence electrons. Because they're metals, they lose. And they have a +2 ionic charge. Group 3A has an S2P1, have 3 valence electrons. They lose those electrons. Oh, sorry, +3. Group 4A is S2P2, 4 valence electrons. The metals will lose and the nonmetals will gain. And they are +4 for the metals and -4 for the nonmetals. Group 5A is S2P3 with 5 valence electrons. And they will gain and end with a charge of -3. Group 6A is S2P4. They have 6 valence electrons. They will gain, the nonmetals gain, and have an ionic charge of -2. Group 7A is S2P5, have 7 valence electrons. They gain more electrons. Their group ionic charge is a -1. And then group 8A, which is your noble gas, is an S2P6. They have 8 valence electrons. They don't do anything. They don't gain, they don't lose for the most part. And so they have no ionic charge. They are not involved in our bonding. Okay. On the next page, this assignment you're going to complete using the periodic table on page 139 will be a great help. You also have the periodic table that you colored and named all of your groups and stuff like that. Remember, everything that was blue or anything that is below the zigzag line is we're going to consider a metal, except for hydrogen, and anything above the zigzag line is going to be a nonmetal. So you will use the periodic table out of the book, chapter 5, page 139, to answer these questions. It's going to ask you a lot of things about different things about the periodic table. Now then, I want to look at this part down here. Now then, fluorine, they want us to write the symbol for the most common ion formed by each of the following elements. So oxygen, its symbol is O, and its ionic charge for group 6 is a -2. Fluorine, symbol is F. Its ionic charge for group 7 is a -1. Cesium is a group 1 metal. Symbol is CS. So its ionic charge is +1. Argon is AR. And it has no ionic charge. And now I'm going to let you finish doing the rest of them. So that's it.